Diffusion, the international science radio show.
We have a bouncer on the doors of perception.
The good, the bad, the ugly.
It gets pretty exciting.
The myths, the truths.
Toxicology.
Astroseismology.
Magnetism. The dark side.
Genetically engineered potatoes.
Planetoid.
Planetoid.
I love that word.
Hello and welcome to Diffusion. Sit back and relax while we transmogrify your brain with weird and wonderful science. I'm Ian Woolf. On this edition, we have a blast from the past from the cassette archives. The year is 2001. The show was called Discovery, and a large team of volunteers produced the show. Listen to Tim Baynes talk about solar storms, and Nick Perkins interviews Professor Srinivasan at an Australian neuroscience conference about the workings of insect minds and how bees are easier to train than monkeys. All broadcast live.
You're listening to Discovery, the national science show that looks at the weird, the wonderful, and sometimes the controversial in our world of science. I'm Nick Perkins, and on this program we'll be taking a look at solar explosions and insect minds. But first up, here's the news with Deanna Coleman.
Environmentalists have been concerned by falling over penguins since the rise of aircraft traffic in Antarctica and the Falklands War. British pilots had claimed that as aircraft flew by, they noticed penguins falling over backwards. A recent study on the island of South Georgia by members of the British Antarctic Survey recorded the behaviour of a group of penguins as two helicopters flew overhead at varying speeds at heights. The penguins, it seems, did not fall over at all, but stopped calling to each other while the aircraft was overhead, and the adolescent birds who were not associated with the nest walked away, much like the behaviour in our houses under the flight path in Sydney when a Boeing 747 cruises over, making it impossible to hear each other. The research team also concluded that the penguins' reproduction was not affected by the air traffic as originally thought. The increase in the number of incubating birds in the observed colony matched the number in an undisturbed colony nearby. Moving almost 6 sextillion tonnes is relatively simple, say a team of astronomers who believe we can shift the Earth into a new orbit further away from the Sun's ever-increasing brightness. Over the next 3 billion years, the Sun's brightness will increase by 40%, making it impossible for humans to survive on our planet. But all we need to do is use the gravitational slingshot technique, where a large asteroid about 100 kilometres in diameter is flung into space, transferring some of its orbital energy and repositioning the Earth to maintain a benign global climate. This simple technique, increasing the radius of the Earth's orbit, would need to be repeated every 6,000 years to compensate for the increasing brightness of the Sun. Gradual outward migration of the Earth would in turn affect the orbits of other planets in the solar system and change their stability, and perhaps other moons and planets could be moved into more favourable positions in the solar system where their climates would support life. But don't go investing in real estate on Mars just yet. This procedure will require some care. If the 100-kilometre diameter big huge asteroid was to accidentally collide with our Earth, then it would wipe out all life on our planet before trying to save it. An optimistic or pessimistic outlook on life may be determined by the way electrical signals in the brain respond to different stimuli. A study was conducted by Stanford University in the US, where 14 women aged between 19 and 42 were shown a range of pictures while their brains were scanned for activity. Each subject was shown both positive images, including happy couples, puppies, ice cream and sunsets, and negative pictures such as crying, angry people, guns and cemeteries. Some women showed strong signs of electrical activity in the regions that deal with emotion when positive images were shown, while others responded much more to negative pictures. When the volunteers were asked to complete a standard personality test used to class people as extroverts or introverts, the researchers discovered an interesting correlation. Those graded as extroverts responded to positive images, but not to negative images. Those graded as introverts responded only to negative pictures. But maybe those introverted women responding only to negative images were just plain pissed off that day.
You're listening to Discovery, the National Science Program. In our first feature tonight, Tim Baynes looks into the sun and sees spots, flares, and a nasty something called a coronal mass ejection.
Like the Earth, the Sun has a magnetic north and south pole. But unlike the Earth, about every 11 years, these poles swap places amidst a tantrum of solar activity. The peak period of this is known as the solar maximum. Churning magnetic fields in the Sun's interior store vast amounts of energy, and during the solar maximum, dark regions called sunspots can be seen on the surface. It is believed that this is where the magnetic fields are particularly intense. In fact, monitoring these sunspots tells scientists where the Sun is in the solar activity cycle. Anyway, the stored magnetic energy is occasionally released as eruptions that come in two flavors. One of these is the solar flare. This is a burst of visible and UV radiation that results from a sudden rearrangement of magnetic field lines in the Sun. The second type of eruption is called a coronal mass ejection, or CME. A good analogy for what happens with a CME is a rubber band being flung across the room. If you imagine the stored magnetic energy as the stretched rubber, and in the same way the rubber band flings itself once it's released, a CME is a self-propelled gigantic ball of ionized gas shooting out from the Sun, carrying the very same magnetic fields that launched it. What we're talking about here is billions of tons of ionized magnetized gas, or what we call plasma, hurtling through space at speeds of 6 million kilometers per hour, held together by its own magnetic field. So what does this mean for your average Josephine on the street? Well, on the 14th of July last year, a region on the Sun's surface, roughly the same diameter as Earth, erupted with a flare of high-energy radiation. This in itself was quite spectacular, but it was also followed by something a bit more ominous. One of these coronal mass ejections spewed from the Sun's outer atmosphere, heading straight for Earth. 26 hours later, this plasma storm hit. After totally frying a Japanese X-ray satellite, the magnetic cloud crashed into the Earth's magnetosphere, dumping 1,500 gigawatts of power. It caused damage to two large power transformers and voltage regulating devices all along the east coast of the US. And they were lucky. You only have to look back as far as the previous solar maximum to find other instances of CME impacts. Early in the AM of March 13, 1989, the Hydro-Quebec Power Company was operating as per usual when the local magnetic field fluctuated violently. Such was the magnitude of this magnetic storm that in only 90 seconds, the entire province of Quebec was without electricity. And Quebec is not a place you want to take a cold shower in March. Some CMEs are more dangerous than others. If the cloud's magnetic field is opposite that of the Earth's when it impacts, then the effect is much more dramatic. The CME then generates a ring current encircling the Earth at an altitude of about 60,000 kilometers. But on the night side of the Earth, this ring current joins into the ionosphere. The ionosphere is a layer of more ionized gas in the upper atmosphere, and it normally has its own circulating current known as the electrojet. The surge from the ring current goes straight into the electrojet, which in turn causes the destructive surges in power transmission lines. It also allows auroras to be observed further away from the poles. Now, since the last solar maxima, there have been about 2,000 new communication satellites launched, a space station or two, and society has generally become even more dependent on electrical devices like mobile phones and ATMs. So what can we do about these solar storms and how they affect us? Well, in terms of stopping them, we can't do a damn thing. But there have been some recent additions to the number of satellites monitoring the Sun that may give us advance warning of CMEs. NASA and the European Space Agency have the Solar Heliospheric Observatory, or SOHO for short, and it lives about 1.5 million kilometers closer to the Sun than the Earth. From its continual observation, SOHO can track a storm after it erupts from the Sun and tell us whether it's heading our way. That might give us 2 to 3 days forewarning. Other satellites monitor the solar wind, a stream of particles and photons being blown outwards from the Sun even when there's no solar maxima. This solar wind may speed up or slow down as CME. There are also 2 more satellites due to go sunny side up in 2004 and 2006. But an intriguing characteristic of the silence before the solar storm is the spectrum of X-rays emitted. In 1999, researchers reported that radiation from magnetically active regions exhibit an S-shaped pattern over the X-ray spectrum. It's known the intense and contorted magnetic field lines are responsible for this, but it still doesn't help us predict when the storm will occur and therefore where it will be heading. As one researcher said, you know the gun is loaded, but you don't know when the gun is going off. Scientists believe the peak of the current solar maximum was July 2000, but the peak is broad, and the whole deal can last 2 years. The heat is definitely on, and it's going to be on for a while.
That was Tim Baynes getting hot about the sun. Still to come, insect brains.
Hello, this is David Bellamy. Honestly, it is. My favourite animal is sea otter, and my favourite community science show, what else but Discovery?
You're listening to Diffusion Science Radio. Send emails to science@diffusionradio.com. We're brought to you across Australia on the Community Radio Network and podcast over the internet on www.diffusionradio.com.
Insects are capable of some very complex behaviour, but what do we know about insect brains and about what they actually perceive in the world? I recently spoke with Professor Srinivasan at the Australian Neuroscience Society's annual conference about insects and their amazing brains. Professor Srinivasan is interested in insect brains. He's found that although their brains are very small, insects definitely don't have the simple minds one might expect. On the contrary, insects use a number of ingenious mental strategies for perceiving their world visually, for navigating effectively through it, and also for learning about their environment to better adapt to and get around effectively in a changing world. Professor Srinivasan is particularly interested in the brain and mind of the honeybee. So, Professor Srinivasan, perhaps you can start off by telling us a little bit about what a bee sees and what sort of mental strategies they use to visually perceive their world.
Yeah, well, it's difficult to put yourself into the shoes or the wings of a bee, actually, and work out exactly what it sees. But we have a rough idea. I mean, bees do have rather good color vision. They have trichromatic color vision, which means 3 color receptor types, just like we do. But they see ultraviolet, which we do not. So they certainly see beautiful patterns in flowers that are completely invisible to us. They also use the ultraviolet light in the sky to navigate and then get to their destination. So their world is probably, in a sense, probably richer than ours because they see ultraviolet, but they do not see the other end of the spectrum. They don't see red. So a red flower would look black to them.
Mm-hmm. Bees are well known, I guess, for their extraordinary abilities with regard to their navigation and flying. So how do they manage it so well? And
yeah, this is what's interesting because the bees do have a tiny brain and yet they do all these remarkable things. A bee will fly several kilometers away in search of food and fly back in a straight line, make a beeline, so to speak, and come back home. And it will avoid bumping into objects along the way and so on. And the way they seem to navigate is to work out how far away an obstacle is. They don't use stereo vision. We use stereo a lot to work out the distance to objects, but they cannot do that because the eyes are very close together. They rely on a completely different trick, and this is to actually work out how rapidly the images of objects appear to move as they are flying along. So if something is very close to them, it whizzes by very rapidly in the eye, and that tells the animal that there's something very close, and they avoid it. If something is very far away, like a distant hill or something, that does not appear to move at all, and they don't worry about it. So they use image motion to see the world in 3D, so to speak.
And the waggle dance of the bee is now famous as a display by which one bee can tell another how far and in what direction to fly to get to a food source. When a bee's following those instructions, how does it know how far it's gone?
Yes, the prevailing wisdom used to be that bees work out how far they have flown by measuring how much energy they consume to get there. But that wisdom is now starting to be questioned. Work in our lab and elsewhere in the world is now starting to suggest that they're using a completely different principle. They're using a visually driven odometer. So as the bee wings its way to the destination, the food source, it measures basically how much the world appears to have whizzed by on the eye. And that amount of image motion is what the bee is communicating to the other bees. So the other bees fly along until they experience the same amount of image motion, and then they know that they're there.
So they can fly and they can see very well. And what about other sorts of higher cognitive abilities, such as their ability to learn about the world and incorporate those memories in changing their future behaviour?
Yeah, well, the more we look, the more amazed we are. People used to think of insects as fairly reflective, simple automatons, but that does not seem to be the case. Bees, at least, are turning out to be fairly flexible in the way they learn things and the way they transfer rules and concepts that they picked up from one situation to quite a different situation. So bees can learn, for example, to recognize particular features of patterns and see them in other patterns that they haven't actually encountered before. Bees can learn to break camouflage in scenes. You can show them initially camouflage objects that they won't be able to detect, but you can give them a hint by showing them uncamouflaged objects, and then you show them the camouflage objects and they can pick them out. So there is this top-down processing that bees display, which surprised us. They can learn to go through mazes, which is probably the first time it's been shown that insects can do it. People have worked with rats a lot to show that rats can go through mazes, and humans, well, some humans can go through mazes, I guess. But surprisingly, bees can do that too. And they can use symbols inside the maze that provide abstract cues on navigating within the maze. So a bee can learn a rule, for example, that says if you see blue in front of you, turn right. If you see green in front of you, turn left. So that's a fairly abstract concept, and surprisingly, a simple creature like a bee can learn that.
How many trials would it take a bee to learn that sort of abstract code of turn left when you reach yellow? And
yeah, not very many at all. I would say about 20 trials. And then they have it down pat. So then you can take them through any maze once they've learned that rule.
So if a bee is capable not only of this bottom-up kind of processing, but can also engage in cognitive style top-down processing and also abstract forms of learning as well as associative recall, does that mean then that, at least in the case of the brain, bigger isn't always better, or are there important limitations on what they can do? And I'm thinking particularly of perhaps their ability to come back from that kind of abstract learning paradigm and communicate that to others in a group.
Yeah, it's a question. I mean, one of the puzzling things is, what we're doing with our huge brains. When bees can do so much with such a tiny brain. I suppose, our brains are programmed to deal with a number of different eventualities which probably don't occur within a bee's lifestyle. I mean, we see it over and over again. If you try to train a monkey to do something, it takes about 10 times as long as it takes a bee to do the same thing. I mean, a simple task, like learning to distinguish between two colors. It's probably not that the monkey is dumber, but it's just looking at it as a task that has many more possible solutions. And probably the cortex is trying to work out exactly what it is that is required, whereas a bee is programmed to sort of learn to fly to a flower, and it sort of explores only the color domain, and searches within that, and manages to learn the solution quite quickly. So I can't give you a really good answer to that question, and I sometimes wonder myself. Someone the other day said that maybe the reason why we have such a huge brain compared to so-called lower animals is that we have this huge administration built into the brain, and the rest of the brain is basically an administrative organization that's supervising the intellect.
Or getting in the way.
Getting in the way, exactly.
Well, Professor Srinivasan, thank you very much for talking to us today on Discovery.
Thank you very much, Nick. It was a pleasure.
That was Professor Srinivasan giving us the buzz on bees' brains. You're listening to Discovery, brought to you nationally on ComradeSat. And now here's Deanna Coleman, who's just popped back into the studio with some late-breaking news.
A warning to all you pill poppers out there, ecstasy may seriously damage your sex life, according to Andy Parrott and his team of researchers at the University of East London. Questionnaires from 768 young people in Rome, London and Manchester have revealed heavy ecstasy users, i.e. those who have taken the drug on more than 20 occasions, were nearly 3 times as likely to report a loss of libido as non-users. This ironic finding of the so-called love drug is possibly related to regular ecstasy use damaging the neurons that make serotonin, which is a key neurotransmitter linked to mood. Although there is no research in humans to show neuron damage is taking place, it has been shown in rats. Parrott says it really is quite worrying. Sunday marks the 53rd anniversary of independence in Sri Lanka. A 5-day march to the capital Colombo is planned by the main opposition party in protest at rising prices and the slow pace of reform. The rally organisers are planning to deploy insect repellent at the rally in case government activists carry out reported threats to release swarms of bees on the protesters. And finally from Moscow, Maria Valiseva is delighted that at the tender young age of 104, she will at last be able to munch her favourite ginger cookies after growing 3 new teeth. Valiseva is the oldest person to grow new teeth, baffling doctors in the remote southern region of Tatarstan, where she lives alone in a small village tending a garden and raising poultry.
Coming up, some extra news with Ian Woolf.
A helmet that lets you see God. In a move that has brought delight to spiritualists, worshippers and atheists alike, Michael Persinger at Laurentian University in Canada has invented a helmet that can cause a religious experience in 4 out of 5 people just by wearing it. Using a technique called transcranial magnetic stimulation, he's been able to induce a surreal experience in people for years. Now he's found that a weak magnetic field, roughly equal to that generated by a computer monitor, rotating anti-clockwise in a complex pattern about the temporal lobes of the brain will cause 4 out of 5 people to feel a spectral presence in the room with them. How people interpret this experience depends on their beliefs and their culture. Spiritualists, or the relatives of someone who has recently died, see ghosts. The spiritualists say that the helmet proves that the brain has a mechanism for detecting ghosts, and this is what the helmet stimulates. Religious people often identify the presence as God, and say that God designed our brain to be able to interact with him, and that this is what the helmet stimulates. Atheists say that they are feeling a spectral presence caused by the magnetic field's effects on their brain, and see it as proof that God doesn't exist, that it's all just brain activity. Dinosaurs are thought to have had a second mini-brain in their abdomens. Now American and German scientists have discovered that humans have a second brain in their stomach that may account for gut feelings. This second brain is made up of a knot of nerves in the digestive tract. It's thought to involve around 100 billion nerve cells, more than is held in the entire spinal cord. Researchers believe this belly brain may save information on physical reactions to mental processes and give out signals to influence later decisions. It might also be responsible for the creation of feelings such as joy or sadness. Professor Prins of the Max Planck Institute for Psychological Research in Munich says that this stomach network may be the source for unconscious decisions, which the main brain later claims as conscious decisions of its own. The second brain was rediscovered by Michael Greshorn of the University of Columbia in New York, after it was forgotten by the rest of science. He says it was first documented in the 19th century by a German neurologist, Leopold Auerbach. He discovered 2 layers of nerve cells near a piece of intestine he was dissecting. After putting them under the microscope, he found they were part of a very complex network. Recent research has already raised the idea that many reactions are made in the stomach. Benjamin Levitt of the University of California has found the brains of volunteers asked to raise their arms only registered activity half a second after the movement had been made. He believes his work implies another part of the body may have been involved in making the decision. This adds support to those researchers who have been saying that stomach infections can affect your nervous system. Irritable bowel syndrome, sleep problems, concentration problems, and even autism are thought to be influenced by a problem propagating along the connection between the stomach and the brain.
Theories were developed by which the many factors in a problem could be numerically related. But the magnitude of the calculations necessary made many such theories impractical. In the last century, the complications of our society have been compounding themselves, and it began to look as though the science of numerical relationships could never catch up. For a long time in the world of numbers, man has been developing tools to help him handle increasing amounts of data.
In the studio with me tonight were Deanna Coleman and Tim Baynes, with technical support by Gina Sartore. Discovery was produced by Christine Brown in the studios of 2SER Sydney and is broadcast nationally on Comrade Sat by the Community Broadcasting Association of Australia. I'm Nick Perkins.
Send your contributions, opinions, helpful suggestions, and donations to science@diffusionradio.com. That's science@diffusionradio.com. Please like the Diffusion Science Radio page on Facebook and rate the show on iTunes. Tell your friends. Follow me on Twitter @Ian Woolf. I edited this week's Diffusion, which is broadcast around Australia to 28 stations on the Community Radio Network, including 2RBM in the Blue Mountains of New South Wales, 8CCC in Alice Springs and Tennant Creek, 2MVR in Nambucca Valley, 3MBR in the Mallee Border districts of Victoria and South Australia, City Park Radio 7LTN in Launceston, Tasmania, and 2XX FM in Canberra. Diffusion is syndicated globally on the National Science Foundation's Science 360 internet radio station and also on astronomy.fm. Subscribe to the podcast on the Diffusion website, www.diffusionradio.com. That's www.diffusionradio.com, and check the website for links, photos and videos about this week's show. If you enjoyed the show, you can explore more than 1,000 previous episodes archived on diffusionradio.com. where the shows are labelled by keywords so you can focus in on the stories you want to hear. Join my patrons at patreon.com/diffusionradio. Make a donation through paypal.me/Ian Woolf. Support Diffusion by buying from the affiliate links at diffusionradio.com/support. Subscribe to the Diffusion YouTube channel at youtube.com/c/diffusionradio. I'm Ian Woolf. Join us inside your audio device of choice for more science wondering next week on Diffusion Science Radio.
Science is fun. It helps you to learn, to know, and to appreciate. When you study science, you may go on field trips. You discover the marvelous interrelationships between all living things. You learn to read the history of the Earth as it is written in rocks and fossils. You find out what makes things tick. Everything from a molecule to a living organism. In the study of science is found the most useful and satisfying knowledge of man. Knowledge of his physical world, its past, its present, and its future. And in your moments of relaxation, now and in the years to come, you will find the study of science leading you into fascinating pursuits. Photography, collecting. Why study science? Study science because you will find in the study of science a richer, more rewarding life.